Just trying to make sure that you hear me. If you can hear me, or if there are any questions saying if you can hear me. Hello? Well, uh, okay, I'm just gonna start by answering the questions. Let's see, the first one I see is explain image to me as the materials. Okay, I guess what we're trying to do is um, start by selecting any one value randomly and then updating the tuple for that particular variable. And so you have the initial state and then you have this new state where you replace the value. So what essentially you're going to be doing is calculating the joint probability of both the states and um, uh, then basically have an acceptance probability, which is the ratio of the new probability to the old probability, and then decide if the new state is acceptable or not. So let's say if the ratio was greater than 1, then you could definitely accept it. But let's say if the ratio was less than 1, then you could maybe have another random value from 0 to 1, and then basically see if the acceptance probability was greater than or less than the newly chosen random value, and then basically decide randomly. Okay, I see. That's right. Absolutely. Uh, does that work? Or that um, can you hear me now, or is it still bad? Okay, I see. It's still pretty bad. Well, I guess we'll have to deal with it for now. Um, I don't know why it's so Well, I guess if you want me to, I could repeat the metropolis tasting sampling one again, just so that if you couldn't hear me before. So I guess what I want you to do is um, given an initial state, pick one of those variables randomly, um, and then you change it. Um, Now you need to calculate the joint probabilities of the initial state and the new state, and then if so, your acceptance probability would be the ratio of the new joint probability divided by the old joint probability, and if this value was greater than 1, then you could count this state as accepted and basically return the new state. And if it wasn't, then you could pick another random value from 0 to 1 and uh, judge if your acceptance probability was greater than the random value, then you could return it, or else not return it. Um, so I guess that is what MS sampling is supposed to do. Uh, um, Based on 5 and 4, set the minimum number of iterations. Would it be okay to not set this minimum over the acceptance criteria? Yes, you could definitely go ahead and try different values for conversions and try setting different values. Um, the next one is, can you give an overview of the big sampling and conversions algorithm as I'm using for this assignment? As it was stated that we can't pass on the evidence, it seems like we're opposed to do rejection sampling or user sampling, right. So I think for this, a lot of people have tried to write their own give sampling function, which fixes the evidence values. Although that's not what I had in mind initially, but um, I'm, I think I'm gonna have to accept that. And uh, in terms of how I had envisioned it, so if I don't expect you to fix the evidence values, then what it's basically doing is sampling all the values and then um, pushing it uh, towards the posterior, but it's also kind of um, like there will definitely come a point where you would get the the last, but suppose from the variables from 5 to 9, I think there'll definitely be a point where you get them at 0, 0, 1, 1. And when you start getting them, that's when you start counting and seeing uh, and basically trying to check for conversions. So if you have 10 consecutive iterations or more, um, if you have 0, 0, 1, 1, uh, and that's when you could kind of compare your procedures for every iteration and see if it's less than 1, like the difference between procedures and it's less than 1. So by difference, I mean for wins, losses, as well as ties, all three, the difference between the new and the previous one has to be less than 1, for 10 consecutive. You can definitely go ahead and increase the number of iterations to the consecutive iterations needed, 20 or 30 or more, and reduce the threshold from 0.1 to 4, have a better convergence or more accurate convergence. Okay. So the next one is not necessary for the function between them. Oh, I don't know why the sound is so bad, but um, I don't know. It's probably because live streaming, and I'm on Wi-Fi right now. But thought it would be good, but uh, okay, so next. Are we supposed to build a mock-up model of size to and present condition probabilities? Um, I'm not exactly sure why you would need to build a mock-up model as such, but yeah, I'm not really sure exactly why you're asking that. Because I mean, if you want to calculate the probabilities, you could just do a sort of joint probabilities given the Markov blanket for a particular variability. Um, what the blanket is, like let's say for a game, you know that it depends on A and B, and so for a game, it's just the Markov blanket is just A and B, whereas for particular team skill level, Markov blanket is. So it basically consists of the games played by those teams and the other teams that they're playing against. Basically, that's the children and the children's parents. So for A, it would be ABB and EVA and then B and E. So yeah, so in order to calculate the probabilities, you can just do a joint probability and then just consider every single possible value for A. So that would be so you'd have three values for three skill levels, or wait, was that four? I think it has four skills. Sorry. So, yeah, so it has three skills. So yeah, or four skills. Sorry. So yeah, for all four skills, you can have um, a different chunk probability calculator. Okay, so um, I say that there's a question where you can hear a lot of background noise. I'm actually sitting in a closed room, so um, I don't know why this is happening. Try moving, but okay, I don't know why this is still. I don't know if you can hear me now. Okay, so going on to the next question. Let's see. I have the one say, can we change the successive iteration number and elimination condition? Yes, you can definitely change it. In fact, I encourage it so that you can converge to a more accurate posterior yes. Um, let's see. Uh, let's take easy one first. That's Jim. I'll be stuck on one big profound inference proceeding for incompatible. So I think with respect to this error, it's mostly because your distributions are not set properly. So what you could do is put your code up on a private post with Piazza, and I can have a look at it. Um, Now, for, um, again, regarding my last question, I need the criteria, so I'm not too worried about setting uh, uh, a minimum migration just to um, I guess for this, I don't know why. I mean, depends on the way you're implementing it. Like, let's say if you're fixing the evidence values, then definitely you could be merging too soon. But it definitely makes sense to run it for more than like 15 iterations or 10 at least to see if it's converging to, like, if it's staying in the same posterior range. Trying to see why is that bad. Try holding my laptop closer to my face, but I don't know if it's gonna help. Let's see. Okay. Uh, Shelly, give me 1 minute. Um, all right, Shelly, can you hear me now? Uh, um, I don't know why. I don't know why it's being so problematic. But, uh, okay, I've been told that I'm louder and clearer now, so it's probably because I'm holding my laptop closer to my face. But I guess I'll have to work with that. Um, uh, okay. So what I could do is, if you couldn't hear me before properly, then I would put all the answers down on the WhatsApp. But I think uh, the most important one was me kind of explaining Metropolis Hastings. So yeah, I'll kind of put a post on that. Um, okay, so the new questions. Mm, uh, okay, so mm, oops. So yeah, the next question is, for MX sampling, should we calculate PX and PX hash and use a symmetric distribution? We also give clarification on proposal distribution and probability distribution. Um, I'm not exactly sure what you mean by symmetric, but I think I read about it on Wiki, so let's see. Uh, um, I guess for image, like I said earlier, right? You just need to calculate the initial state's joint probability, and then uh, basically select any one variable, and then um, update it or like change it, and then calculate the new joint probabilities, and then if and have like another acceptance ratio where the acceptance ratio is the new probability divided by the old probability, and then if this acceptance probability was greater than 1, then you could return the new state sample, but if it was less than 1, then you could have another random variable um, decide if you wanted to return the new state or the old state. Um, okay. Um, Also, pick randomly a uniform distribution between 0 and 1. Can you clarify what is done with the number between 0 and 1? Richard, so I'm not exactly sure for which part this is. Um, I think you mean Metropolis. Um, but let's see, where is it? Yeah, I'm not sure exactly, Richard. Pick uniformly. Yeah, I'm not sure where do you want me to use this 0 to 1 random number. So if you could re-ask this question again. Uh, okay, so if I'm louder, it's still muddled, but it's clear. Okay, I will be louder. Okay, so the next one is, I feel like I'm doing something wrong in my gives. I feel like K into PG down to P should be a 4 vector, but I don't see how considering the first two games. Return a 3 vector. So Chris's question, K into PG1, G2, gain 1, which is 2, going into 2, 2. Chris, I'm not exactly sure that your equation is correct. Uh, what exactly are you trying to calculate? So K into 1, which is 2, then 1, 2, 2, which is 3, then 2, 3. And yeah, I'm not sure, Chris, what that equation is, but yeah, sorry. Uh, so the next one is give sampling update step. I randomly select a node, and this node will either be a team node or match node. What I do not understand is how to compute a distribution for this node. Well, in order to compute the so what you're trying to do in give sampling is basically update a variable's value to something new, but you'll be doing that using the underlying distribution, which is ideally what you would be doing is just take a variable, like pick a variable randomly, and then for every variable, let's say you picked team A, then you need to compute the four different values for which uh, the four for each of the different scale levels possible, and you will do that using like basically just computing a joint probability on the current variable and the Markov blanket of that variable. So that should give you four joint probabilities, and then uh, you can normalize them. So let's say you have probabilities which are, and they may not necessarily sum up to one. So you need to kind of normalize them, and then do like a cumulative sum of them. Like a cumulative sum would basically, so let's say if you have probabilities zero point 0.2, zero point 0.4, and zero point 0.8. So after okay, so basically after normalizing, you could get values which are zero point 0.2, zero point 0.2, zero point 0.4, and again 0.2. Then your cumulative list would basically be um, 0 to zero point 0.2 to zero point 0.4 to 1. Wait, zero point 0.4 plus 0.6 is 1. Yeah. So, and once you basically are trying to divide the entire range from 0 to 1 into buckets, and then pick another value randomly, see which range it lies in, and whichever range it lies in, that's the value you use to update your variable. Um, I hope this makes sense. But yeah. Uh, okay. MH question. Calculate probability over probability inequality. Is this the new? Is the probability considering the entire state space, that is all skills and all match outcomes is specified? Um, yes, that is going to be the entire state space's uh, probability. Yes, the giant probability of, yeah, the entire thing. Um, um, so okay, so Chris is saying I'm trying to calculate the probability of the team skill given its Markov blanket. Um, so the probability of the team of that particular probability would just be um, like a multiplication, right? So Bayes' rule basically says that you multiply all given evidence variables. So uh, yeah, so basically just compute the joint probability. That's what I'm trying to say. Um, if that's clear. Um, uh, okay, next one. How do we come up with the proposal distribution of done team skills is team skills of I is um, match results is So I guess with Jeffrey, your question, um, I'm not entirely sure if I understand it correctly. Maybe we could take this up on Piazza, but yeah, I think let's just discuss this more on Piazza. Okay, sorry. So let's see. There is an MH follow up, which is saying, super clear audio now. You said, okay, what I'm doing basically is sticking my laptop in my face. But yeah, you said pick a random uniform variable between 0 and 1, but what do I do with this? Right, so for MH, once you calculate the acceptance probability, which is the ratio of the new to the old, what you can do is, so if this acceptance probability is greater than 1, then you can just return the new state. That's your new sample. But if it's not, then it's probably going to be a value from 0 to 1. Now, if you want to decide if you want to accept the state or not, you could generate a random number from 0 to 1, and if your acceptance probability is greater than this random number, then you can return the new state, or else just return the old state. um, so yeah, that's what I meant. Now, okay, I'm glad you can hear me now. Uh, let's see. I feel like for some reason the lecture and book algorithms do not seem to match with the method signatures we are given for Gibbs. Unless that's something buried in the gradient lab I'm missing here. Some okay, well, I guess for the next batch we will definitely include uh, the evidence variables as part of the Gibbs sampling method, the function. Only because yeah, it does make more sense. I kind of had a different approach towards Gibbs sampling, which is why I didn't really I didn't really recognize the need uh, for having the evidence variables, only because so the Udacity video said that you need to kind of tweak just one of the variables, and that's what I meant by one iteration. So I didn't really need the evidence variables for doing that, although pretty much the other algorithms in the book or on Wiki do say that one iteration means that you update one variable and then you let it update all the other variables as well. So yeah, I'll definitely keep that in mind, and make sure that the next batch doesn't have to go through this. Yes. Um, okay, so we're done with all the questions. If anybody has any other questions, they can still post, or else there's always Piazza. So okay, I'm gonna stay on for another 3 more minutes, and if we don't have any more questions, then we can call it an end. Just for curiosity's sake, can you do a small test without having the computer attached to your face to see if that brings back? Uh, well, um, okay, so right now I'm in a normal position. Can you hear me now? Uh, I I don't know if the disturbances was less now or not. Um, Okay, great. So you can definitely hear me now. So this is the set of equations I was using. Okay, this is question by Chris. This is the set of equations I was using to get my Gibbs sampling for teams. Um, okay, let's see. Um, so your first equation is correct. Then the second one, which is saying probability of T2 given the Markov blanket, yeah, that's correct. Now the third one is K into G1 gain 1. Uh, yeah, I think the last one, there's something wrong with it. Uh, can you give me a reason why you've chosen that? I'm just trying to see, or maybe I could be reading it wrong or understanding it wrong, but oh well. Mm, I mean, I guess you could go with it if people have been successfully been able to converge using that equation. Although I'm not exactly sure if that's the correct way to do it. Um, uh, so let's see. I'm just gonna pull that post up. That's probably in the post 514. Um, I'm trying to search for. Uh, um, well, yeah, it's a long thread, but so as I can see one post where P of B is dependent on the Markov blanket, which is um, yeah, and for the next part, I think Brian has posted that it should be equal to Yeah, so I think I see this equation from Brian, which is 4 days ago, which does seem correct. I don't know if that was the same one that you were referring to, but yeah, that's correct. That's the one. Yeah. Uh, yeah, that's the one. That's the one that I'm looking at. So yeah, that's correct. Yeah, I probably may have misread the one that you typed in. So um, yeah, sorry about that. Um, yes, Brig. That's correct. So that's what you're trying to do, right? You are kind of using Bayes rule to get the giant probabilities, and then yeah. Okay, it's all right. Chris. Um, awesome. So anyway, any more questions? So how are you all doing so far? I mean, um, just wanted to get to know. Are you done with Gibbs convergence or Metropolis convergence, or which part? And which was the most tricky part for you guys? Um, all right, Chris. Great. Let me know if you're stuck. I'm gonna still try and help out on Piazza if I can. All right. Well, I guess we're done. And oh, the whole thing. We have another post. Well, yes, and I mean, it's definitely um, less work in terms of you just have to implement just two algorithms, but like in terms of coding, there's not many lines of code that go into it, but yes, there is kind of a steep learning curve to Bayes nets and probabilities and the two algorithms. Yes. Um, I'm glad the discussion helped though on MH. Okay. Well, you're welcome, Hasti. Thank you. Uh, Brig says the learning curve is pretty steep. I'm new to MH. I'm on to MH, but I'm not quite sure. Oh well. Yeah. Uh, I guess I mean there's no way really that I could provide you more tests for Gibbs and MH, but I probably think that the function definition with evidence variables, like for Gibbs and MH, if they had the evidence variables, it would have caused a little less confusion. So yeah, I'll make sure I do that. But in terms of implementing, there's just not many ways you can do it, right? So Gibbs is kind of a fixed algorithm. MH has a kind of fixed algorithm. So you're doing that, you should be good to go. Um, um, yes, Chris, that's right. Understanding base nets can be a little tricky. So, um, honestly, I think getting my head around the first side is most hard because it's trying to place true and false with what it meant in context of the. Oh, yeah. I honestly thought that giving the example models would have helped. Uh, but uh, I mean, a lot of people were kind of they were just like, I have so many private posts on Piazza just with some small mistake here and there, and people are not sure. So that happens, and well, yeah. I mean, I pretty much am answering like about 50 private posts per day, uh, just just to handle these small bugs in their codes, and yeah, I can understand it can be a little yeah, annoying, but okay. Well, so that's done. Well, okay, so if you guys still have any more questions, you can shoot me up on Piazza and I will try to answer as fast as I can. Although I do have a big assignment due tonight, so um, uh, you're welcome, Chris. Yes. Um, yeah, so that's how kind of it works, right? So pretty much all the TAs are taking in one assignment each, and uh, yeah. So I'm glad I could help. Well, thank you. Okay, great. So seems like we've run out of questions. So I will, yeah, I think I'm gonna end this now. So let me know if you guys have any more questions, and I will definitely try to answer them on Piazza. Oh, all right. Bye bye. Good night.